In this example, we need to solve this log equation. So we're given 3 log base 2 of x equals negative log base 2 of 27. Now, when you're trying to solve a log equation, we need to either get both of our logs on the same side, if that's at all possible, or we want 2 logs with the same base to be equal to each other, which is what we have in this case. Now, when we're trying to solve 2 logs that are equal to each other, in order to solve them, really it should just be log of whatever your argument is times or equals log of whatever your argument is. So any of our coefficient factors probably need to be put back into the argument using the power rule. So that's the first thing that we're going to do here. So I'm going to take this 3 and I'm going to apply it as the exponent to the x, and then take this -1 and apply it as the exponent to this 27. So we're going to end up with this new log equation. So it's going to be log base 2 of x cubed equals log base 2 of 27 to the negative first power. Now, we have the property that says if you have 2 logs that have the same base and are equal to each other, then their arguments must be equal to each other. So we can essentially just drop the logs and set the arguments equal to each other. So when we do this, we're going to get that x cubed should equal 27 to the -1 power. If you recall the properties of exponents, 27 to the -1, that's just saying 1 over 27. And to solve this, since x is being cubed, we can take the cube root of both sides. Take the cube root of this and the cube root of this. And we will end up with x equaling, so the cube root of this, remember, is the same as saying the cube root of 1 over the cube root of 27. The cube root of 1 is just 1. The cube root of 27 is 3, because 3 cubed is 27. Now, anytime you get an answer to a log equation, you need to make sure that your answer is valid. If you recall, the argument of a log must be positive. So you need to make sure that when you take your value that you got as a result and you plug it back into your log equation, that it keeps your argument positive. So 1/3 plugged back in is positive, so this does in fact work.